Usually, when we pull up a map on our phones, there is this underlying expectation of just, well, absolute certainty, you know?
Oh, yeah. You want that blue dot to be exactly where you are.
Right. You look down, you see that little glowing blue dot, and you trust it implicitly. You are here. The intersection is there.
It feels binary.
Exactly. It's clean, definitive data. We crave that visual guarantee because, well, we want the world categorized neatly.
But the moment you step into the environment of, like, a complex industrial plant, that comforting certainty completely vanishes.
It really does.
Yeah.
You find yourself looking at these digital interfaces and 3D renderings that are quite often just complete illusions. They're masking massive data gaps.
Yeah, the slick interfaces can be incredibly deceiving.
So today we're taking a deep dive into a draft press release from a company called EON AI Ventures. And they are exposing a massive bottleneck in how digital replicas of these industrial facilities are actually built.
And our goal today is to decode the implications of this because it's fascinating.
It really is. Because far more importantly, they are attempting to solve this bottleneck by doing something almost unheard of in modern software. They are actively monetizing their own platform's ignorance.
It is a remarkable pivot in how enterprise software is positioned. I mean, we are looking at their new product announcement for something called the EON Universal Twin Ladder.
Which is such an interesting concept.
It is. But to understand why this product architecture matters, we have to look at the historical friction, right? The friction involved in creating a digital twin in the first place.
Yeah, because for a long time, the barrier to entry has just been catastrophic for most facilities.
Exactly. We are talking about a resource-intensive, highly physical process. If a plant manager wanted a virtual replica of their facility, it required, shutting down entire sections.
Right, sending in teams equipped with laser scanners and 360-degree cameras.
Yeah, capturing literally billions of spatial data points.
They had to generate these massive point clouds, right? You capture the real-world geometry, upload terabytes of data, run it through heavy registration software to stitch it all together.
And then you wait weeks or even months before a usable model appears on a screen. The upfront capital expenditure is just enormous.
So the time and cost basically locked out the vast majority of mid-tier industrial facilities.
Precisely. And what EON is attempting with the Twin Ladder is to bypass that initial physical site survey entirely.
Which sounds impossible at first.
Right. But they have built this tiered system. And they start at the bottom rung, which they call the Twin Sketch. The fundamental shift here is that the Twin Sketch requires zero physical presence.
Wait, zero?
Zero. It is generated entirely by ingesting standard P&IDs.
Okay. Those same static 2D PDF diagrams sitting on every plant manager's hard drive right now.
Yes, exactly those.
Yeah.
The system uses machine vision and natural language processing to parse the unstructured data within those flat PDFs.
But it isn't just reading text, right?
No, the AI relies on symbol matching algorithms to identify standardized industry icons. So distinguishing a centrifugal pump from a gate valve, for instance.
Oh, wow.
Yeah, and then it extracts the alphanumeric tags associated with those symbols and traces the drawn lines connecting them.
So it is essentially translating a flat visual drawing into a topological relational database.
Exactly. It maps out the logical node link structure of the entire system before generating a single 3D asset.
And it does this incredibly fast. Like, the press release details a working trial where a customer handed over a standard P&ID package.
I love this trial data.
It's wild. The EON system parsed the drawings and generated a twin sketch containing 198 uniquely tagged parts and 40 proposed piping connections.
And crucially, the system reported on every single data point. Nothing was discarded silently.
But the most disruptive detail of that trial isn't even just the fidelity of the parsing, it's the compute cost.
Oh, right. The machine reading process for that entire drawing cost under 5 cents in cloud processing power.
5 cents?
I know. When you consider that a traditional point cloud site survey runs into the tens of thousands of dollars, a 5-cent compute cost completely flips the economic model of digitization on its head.
Okay, let's unpack this. The economics are wild, yes, but we need to look at the underlying spatial logic here because I see a massive red flag.
Look at here.
Well, the P&ID provides topological data, right? Like what connects to what. It does not provide topographical data. It doesn't know where those things actually sit in 3D physical space.
That is correct. EON admits the spatial arrangement in the Twin Sketch is purely illustrative.
So it's less like building a precise 3D environment and more like I don't know, giving an AI a list of ingredients and a picture of a cake and asking it to guess the recipe.
That's a great way to put it, yeah.
It knows exactly what components are in the room,
Mm.
but the spatial relationship, how those ingredients are actually layered in the physical plant, is just an educated hypothesis.
Right.
But if that physical layout is a guess, isn't that inherently dangerous for an operator relying on the twin during a crisis?
This raises an important question. That gap between a schematic guess and spatial reality is a massive technical liability.
Exactly. If an operator assumes a valve is 3 feet from a doorway based on this illustrative sketch, and in reality it's on a mezzanine level on the other side of the building.
The software has actively hindered the response, yes. However, we have to evaluate the utility of this first rung in its proper context.
Okay, how so?
Even without spatial accuracy, an automated, perfectly transcribed inventory check has immediate ROI. Moving from a dusty PDF to a searchable relational database where you know with absolute certainty that those 198 specific parts exist in the logical chain, that is a massive operational upgrade.
Yeah, that makes sense. Just having the list digitized is huge.
But the inherent spatial risk you pointed out is the exact reason why a purely illustrative sketch is insufficient for complex engineering tasks. It's why EON had to build the next tier to begin bridging that gap.
Because having generic gray boxes floating in a digital void doesn't help a mechanical engineer figure out if they can physically fit a wrench between two specific pipes.
Exactly. They need structural context.
But the constraint remains, right?
Yeah.
We're still avoiding flying a survey team out to the physical site. So how do you give engineers spatial context without a point cloud?
Well, that brings us to the second rung, the Twin Forge.
Twin Forge,
The
right?
Twin Forge tier addresses the visualization deficit by populating that skeletal node-link structure with hyper-detailed parametric models.
They power this with what they call the living library, right?
Yes. And this isn't just a collection of static 3D meshes. It is a dynamic catalog of industrial components. The release notes it currently holds 363 fully modeled industrial components.
And 8,000 subcomponents.
Exactly.
But the technical mechanics of how these components interact is what really caught my attention.
Yeah.
EON designates 241 of these as having real connection point anchors.
That's the game changer.
Yeah, because when the topological graph dictates that pump A connects to valve B, the living library models aren't just shoved next to each other.
Right. The models possess metadata about their own physical geometry.
They know exactly where their flanges and nozzles are located in 3D space.
And the software uses those anchor points like magnetic nodes, mathematically generating piping splines that auto-route and attach exactly where the physical connections exist on that specific hardware model.
That is wild.
They are referred to as smart components because of that embedded intelligence. They are aware of their equipment class, their spatial dimensions, and crucially, their simulation limits, like pressure tolerances or flow rates.
Oh, wow. So they actually understand their own physics.
Yes. And from a scaling perspective, this library architecture is brilliant. It creates a network effect. Every time EON deploys the software and models a new obscure valve for one customer, it enters the global living library.
So future customers indirectly benefit from the parametric modeling already completed.
Exactly. The visual and functional accuracy of the platform compounds with every deployment.
Okay, I see the scalability, but I feel like we are walking right back into a severe psychological trap here.
How do you mean?
Well, we are taking an illustrative spatial guess, that hypothesized cake recipe we talked about, and we are dressing it up with hyper-realistic parametric 3D models that auto-route piping flawlessly.
I see where you're going with this.
We are masking a low-confidence spatial layout with high-fidelity graphics. Doesn't that gloss finish completely warp user perception?
It absolutely can.
The interface is going to look incredibly polished, which might trick a facility manager into thinking the twin is perfectly accurate when the room's layout is still entirely unverified.
You're spot on. That illusion of accuracy is exactly the liability industrial operators are terrified of.
Yeah, because it looks real.
Human psychology defaults to the aesthetic usability effect. If an interface looks slick and seamless, we implicitly trust the underlying data. We assume high visual fidelity equals high data integrity.
Which is so dangerous here.
EON realized that if they just stopped at this beautifully rendered stage, they wouldn't be solving a problem, they'd be creating a severe safety hazard. The operators would trust the slick UI right up until the moment they needed it, and the data proved false.
Which brings us to how they are attempting to dismantle that illusion. Because if realistic graphics inherently deceive users into assuming a physical survey occurred, the software needs a heavy-handed mechanism to force reality back into the picture.
Yes, and this leads to the top rung of their architecture, the twin mirror.
The twin mirror.
The twin mirror represents the traditional survey-grade digital twin. This tier relies on actual photogrammetry, real-world geometric data, and human confirmation of the topological connections.
So this is the real deal.
Yeah. EON designates this specific tier as the twin of record. It's explicitly intended for active field use and deep integration with maintenance systems.
But the real breakthrough isn't the existence of the surveyed tier, is it?
No, not at all. The defining feature of this entire product suite is how it handles the unsurveyed tiers. EON built a user interface that violently refuses to hide its own data gaps.
That is so rare.
The software loudly and permanently states exactly what it does not know. It is a complete paradigm shift in UI design.
Yeah, the release says every digital twin in the ecosystem is branded with a permanent tier badge burned into the display.
And the user cannot toggle it off. The interface is purposefully designed to report absences.
The visual language they use to separate verified data from guessed data is striking too. Components that were positioned based on actual photographs or point cloud data are visually distinct from parts that are placed via those illustrative algorithms.
And if the system parses a component from the P&ID, but the living library doesn't possess a slick 3D model for it yet, the software refuses to guess.
Right. It doesn't pull a similar-looking model just to make the screen look pretty.
Exactly. It drops a plainly labeled generic gray box into the environment. It is visually jarring on purpose, ensuring the operator cannot mistake it for verified equipment.
It forces a confrontation with the limitations of the dataset.
It really does. If a user is navigating a twin built purely on that twin sketch tier, the software explicitly prints a warning on the screen stating that no physical survey, no photograph, and no human verification was involved in the placement of the assets.
And furthermore, every single twin ships with this relentless audit feature.
Oh, the audit feature's fantastic.
It operates like a roll call, right? Continuously displaying how many tags from the ingested drawing were successfully matched to the library, how many remain unmatched, and listing the specific nomenclature of any part that was dropped or ignored by the parser.
Right, and here's where the technical mechanics behind that audit feature get really clever, specifically regarding optical character recognition.
Okay, here's where it gets really interesting.
Yeah.
EON addresses the reality of dealing with legacy PDFs, right?
Yes. Because frequently, an old engineering drawing might contain text that isn't actually encoded as text data. It's saved as outlined artwork.
Like essentially a vector drawing of a word, relying on curves and paths rather than embedded font data.
Exactly. And machine vision algorithms struggle immensely with this because they are looking for standard typographic patterns, not custom vector shapes.
So when the EON system encounters this and fails to fully parse the string, it refuses to generate a fake confidence score.
Which is huge because standard AI models often try to smooth over those errors to maintain the appearance of competence. They will hallucinate a character just to complete the string.
But the EON audit explicitly labels its own census of that specific document as partial. It openly declares, the data here is incomplete because I could not read the vector paths.
It prioritizes extreme transparency over appearing flawless.
It really does.
What's fascinating here is the business philosophy driving this design choice. It's articulated perfectly in the source material by EON AI Ventures founder Dan Lugersgaard.
Oh, I love this quote.
He states, "A twin that looks surveyed but was not is the fastest way to lose a customer's trust. The moment an operator finds their pump on the wrong side of the skid, everything else you told them is in question."
Yeah, you lose the trust once, and the multi-million-dollar software deployment just becomes useless.
Exactly. He follows that up by saying, "We would rather ship software that says what it does not know. That is the product."
That framing is profound for the tech industry.
It is. The disclaimer is not a legal afterthought tucked into a terms of service agreement. The disclaimer is the primary feature of the software.
They're literally monetizing honesty. The inherent value of the platform isn't just the parametric 3D modeling.
No, the value is the system continuously calculating and displaying its own margin of error. It's telling the operator exactly how much weight to give the visual data at any given second.
Because in high-stakes industrial operations, misplaced trust in a digital system doesn't just result in a minor inconvenience, right?
Right. It results in catastrophic downtime or severe safety incidents. By forcing this radical transparency into the UI, the software demands that the operator engage critically with the tool.
It prevents passive consumption of a slick interface.
Exactly. It treats the human operator as an intelligent, necessary partner in the data validation process.
So, looking at the deployment timeline from the press release, EON is pushing this aggressively. The lower tiers, Twin Sketch and Twin Forge, are currently entering customer trials.
Yep. And organizations can initiate a trial by simply handing over a single P&ID, completely bypassing the massive friction of a physical site visit.
Meanwhile, the fully verified top tier, the Twin Mirror, is already operational with EON's existing industrial client base.
The market response to those lower tiers will be the true test, though. It will reveal whether enterprise customers are mature enough to accept software that is explicitly designed to flaunt its own imperfections.
Right, like will they accept that in exchange for speed and accessibility?
Exactly.
So what does this all mean? Which brings us to why this matters beyond just the industrial sector. We interact with complex software systems every single day that operate on the exact opposite philosophy.
Oh, completely.
Consider the social media algorithms curating your feed, the mapping apps routing your commute, or, the generative AI chatbots summarizing your research.
They are universally engineered to conceal their black boxes.
Yes, they hide their biases, their missing data sets, and their algorithmic guesses behind these incredibly polished, seamless user interfaces. They project omniscience.
And EON is proving that in environments where the stakes are actually real, aggressively self-reporting your limitations is a vastly superior methodology for establishing genuine user trust.
If we connect this to the bigger picture, it highlights a critical vulnerability in our daily technological interactions.
When software presents a flawless facade, it lulls the user into intellectual complacency. We just stop interrogating the output.
We accept the blue dot on the map as absolute truth, even when the underlying data is degrading.
But a system that actively highlights where its data is weak forces the user to maintain their critical thinking skills. It is just a much healthier dynamic between human and machine.
It really is.
Yeah.
So if multi-million-dollar industrial tech companies are realizing they must prioritize unswitch-offable disclaimers of their own ignorance over seamless visual illusions just to maintain operational trust, we really have to look at the tools we use daily.
Absolutely.
What would happen if you demanded that exact same level of radical structural transparency from the algorithms and AI systems embedded in your personal life?
That would change everything.
Imagine if your social media feed or your favorite AI tool featured a permanent, immovable tier badge, loudly and constantly announcing exactly what it did not know. It would entirely rewrite your relationship with the digital world.
It's definitely something to think about.
Thanks for joining us on this deep dive. Keep questioning the map, and we will see you next time.